minus 4, minus 6, minus 8, minus 10, and minus 12. Okay. So we know that at 8.154, we have a tensile of 52.732. Okay. So sketch. Okay. So we have 8.154 is somewhere around here, and then we have a 52 point. So 52. This is just eyeball sketch. Okay. So we have our tensile. Let me look at our tensile. 52.732. Okay. So 52.732, and then we have 8.154. Okay. So this is our first dot, and then our next dot is 11.846. 11.846 and minus 67. So minus 65, 60, 11, 11.8. Okay, so it's below. And then we have what? 67. So it's somewhere around here. As I said, this is a sketch. So we have minus 67.174. And then you have 11.846. Okay. So I'm going to sketch a line. Okay. Do we need to graph for text exam for the do we need to graph for test exam of the question doesn't ask? If you sketch the distribution, you're graphing already. Okay. So for this case, I'm just doing a sketch, but you need to label. Okay, things like that are important. You need to label them. Okay. Right. So now, from the sketch, we realize there's a shift. Okay, we realize, what do I mean? We realize there's a shift. So there's a shift downwards. Okay. So we know that this line over here is our centroid. Right? Our centroid is determined geometrically. And we also know that this line now is our neutral axis. Okay. We call it neutral axis because the stress is equal to what? 0. Okay. So as I said, I'm going to use simple math. I don't want you all to memorize the formula. Okay. So let's deal with simple math. So we know we are going to find the gradient. So we know that this is equal to y is equal to mx plus c. That's a function, right? It's a linear equation. Then we know that it's a linear equation. So the gradient is equal to the change in y divided by the change in x. So it's a positive slope. So it's equal to 52.732 plus by 67.174. No. What am I doing? The y is, sorry. The y distance is 20. Right? Divide by 52.732 plus by 67.174. So this is equal to 20 divided by 52.732 plus by 67.174, close bracket. It's equal to 166.797 okay, times 10 to the power minus 3. So that's the gradient. Let me do it again. 52.732 plus 67.174, 20 divided by, 166.797, okay. Then we put into the equation y is equal to 166.797 times 10 to the power minus 3, stress x plus by c. Okay, c represents the y-intercept. Okay, so now we need to substitute. I call this equation 1. Okay, we substitute 52.732, 8.154 into equation 1. So we are aware that this is our stress x value, this is our y. Okay, so from here you have 52, or you have 8.154 is equal to 166.797 times 10 to the power minus 3 multiplied by stress x 52.732. My writing is getting worse. Then plus by c. So c is equal to, so 8.154 minus by 166.797 power minus 3 times by 52.732 is equal to minus 0.642 millimeters. Okay. So what this means, the minus means the shift is downwards. Like you can see over here, this is what? This is in fact minus 0.642. Okay. So as I said, for eccentric loading, the centroid and the neutral axis are not in the same position. So when I ask you to sketch, you have to sketch the offset, okay, and determine what is this value over here, the offset. Okay. And then if the question were to ask to like sketch the stress field, now all you need to do is just do this. Okay, so this is in compression. Okay, so down here will be in what, tensile already. Okay. So that's how you sketch. Any questions so far?
Sorry, what if the question?
Yes.
What if the question asks to find the stress at point B?
Yeah, so you to find the stress at point B, right? You know this distance, yes or no? Right?
Yeah.
And you know that it's going to be in compression. Okay, so I'm just going to write something on the side. So stress X at point B, right? So the axial load is still the same, right? However, it will be in the what? Tensile mode, because it's above the what? It's above the centroid, yes or no? Point B is above the centroid, so the bending moment will induce a tensile. So this is still 400 multiplied by 0.05 plus by 8.154 times 10 to the power minus 3. Then divide by 3.88 times 10 to the power 9 minus 9. This distance now is equal to what? 8.154 times 10 to the power minus 3 minus by 4 times 10 to the power minus 3. Yes? Right?
Yeah,
Because
makes sense.
you have 4 over here. What is this distance now? Right?
Okay.
Okay, so this will be equal to 3.846 times 10 to the power 6 plus by 0.05 plus by 8.154 power minus 3. Wait, 0.05 plus 8.154 power minus 3 times by 400 divided by 3.88 power minus 9 times by 8.154 power minus 3 minus by 4 power minus 3, close bracket, is 24.904 times 10 to the power 6. So this is 3.846 plus the 24.904 power 6 is equal 3.846 power 6 plus 24.904 power 6 is equal to 28.75 times 10 to the power 6 Pascal. It's just a distant change. Let me do it again, okay? 8.154 power minus 3 minus by 4 power minus 3. Okay? Times by 400 times by 0.05 plus by 8.154 power minus 3, close bracket, divide by 3.88 power minus 9. 24.904. So 24.904 plus by 3.846 is equal to 28%. Okay?
Okay, thanks.
Sir, what if we are asking for a point at the centroid? Is that means the y is 0?
Say it again.
Well, like you just calculate the point at B. What if the
Yes.
point is at the centroid? Is that means the y is 0?
Yes, but the stress is not equal to 0. The stress is equal to 3.846.
Okay, thank you.
Right? Because at the centroid is a geometrical function, yes or no? It's not a stress field, okay? Okay, you guys are creating questions for me now, you know? Right, so that is eccentric loading. And the final topic for your term test, okay, is known as centric.
So please scroll up a bit. I just want to see the last bit. No, like the last page.
Yes.
Yeah, that part.
Okay. So the last topic for your term test is centric. Okay. Unsymmetrical loading. Okay. This is going to be your last section for your term test. So what do we mean by centric unsymmetrical loading? Okay, so I'm going to, now what does unsymmetrical means also is important to know what does it means, okay? So I'm going to draw a cross-sectional view of a structure. So 2, 4, 6. Okay. And I'm going to sketch our transformation. This is our Y, Z rotation in the X. Okay. So what we are viewing now is the cross-sectional view. Then I'm going to sketch our centroid on both axes. Right. So now our moment is applied in this direction. Wrong color, come on. Our moment is applied in this direction. So this is our moment. Okay. So the moment is tilted at a certain angle, theta. And it's tilted from the what? From the z-axis. from the ZZ axis. Okay. So it's tilted a certain degree theta, and that's where the moment is applied. So when you use the right hand rule, right, the moment is doing this. Okay. So now the moment is acting, has two components now. Okay. So one component is mz. So this is our mz. Mz is equal to m cos theta. Sorry, I will not write over that. My apologies. So mz is equal to m cos